So we need to get ready for our test. I'm sorry I'm not here today. Thank you for your flexibility and your professionalism as we kind of work through this in preparation for our exam. So Unit 5 test preview. Want to make sure you are comfortable and confident going into our exam next week on Tuesday. So what to expect? First 15 multiple choice questions will be on Canvas. You will need Lockdown Browser for that. You guys know the drill. They're going to be 2 points apiece. So 30 points coming from the multiple choice. And then we're going to have 10 written nomenclature questions. So nomenclature is just writing and naming. So those formulas, so it'll probably be 5 formulas. Give me the names. 5 names. Give me the formulas. It also is going to give you some scratch paper for that online portion. So there'll be the test part on the front, scratch paper on the back. You will be using your green laminated periodic table. So please plan accordingly. You will not have the back of the periodic table. You need to be able to pull the charges for most of the common ions from the column on the periodic table. And then there's those 7 polyatomics that you just got to memorize. Hopefully you've been taking some time with the flashcards, making sure you're getting those in place. 40 points total. It's been a pretty short unit, and so the test isn't quite as big as some of the other ones that we've had. Want to check it before you send off for Turkey Day. Cool. So stuff to know. Our different properties for our ionic compounds. This was that lab that we did with the kind of crystals, and we're looking at conductivity. So that's our ionic properties lab. Ion formation, what actually has to happen in terms of the electron transferring from the metal to the non-metal to then form these ions that stick together. We should be able to describe ionic bonding. We should be able to define it, metal, non-metal, transfer electrons, and actually think about and talk through what happens in order to form that ionic bond. And then we spent quite a bit of time. We actually spent this whole week looking at how we name and write our names and formulas for our different groups. And then, of course, those polyatomic ions. Pretty straightforward. Just got to make sure we know what we're doing so that we don't get caught unaware coming back. So a couple of just practice ones here I want to talk through. Feel free to pause, try it, listen to the explanation. It's a good way to kind of step through these as we're kind of looking ahead to our test. So ammonium phosphate, so pause. Ammonium phosphate. Ammonium is NH4 1+, phosphate's PO4 3-. When you put them together, you end up with NH4 3 PO4. If you want to know how many total atoms are in that unit or in that molecule, you would have to distribute the 3 in. So it's 3 nitrogen plus 12 hydrogen gets us 15, plus 1 more phosphorus is 16, plus 4 oxygens is 20. So it's 20 atoms total. Your math teacher's proud. You got to distribute if it's outside the parentheses. Cool. Properties of ionic compounds. Give this a shot. Ionic compounds, they are hard, brittle crystals. They got a high melting point. They dissociate in water. They actually split apart. They dissolve into the water. That's why they conduct electricity as a solution. But they can't as a solid. They conduct when dissolved, not as a solid crystal. So properties coming out of the lab. Good to refresh those and review those. Cool. Could you draw the Lewis structure for the following ions and atoms? Calcium would have 2 dots. Calcium 2+ would have no dots. Oxygen would have 6 dots. The oxide ion would have 8 dots around the O2- ion. Cool. Which of the following are ionic? Give you a second. Pause it. Remember, for an ionic compound, we're looking at a metal and a non-metal. So I think our first one definitely is a metal, non-metal. That last one's the tricky one. Ammonium, NH4 is technically 1+. It is an ion, so it can bond ionically, even though technically it's not a metal. Watch out for that one. That one's tricky. Cool. Could you draw a Lewis model to show how sodium and chlorine make sodium chloride? We saw this one before. Our sodium gives its 1 electron to the chloride, and then we've got these charges that stick us together. Cool. Self-check. Write the formula and the charge for the following polyatomic ions. Pause it. Sulfate, SO4 2-, carbonate, CO3 2-, acetate, C2H3O2 1-, nitrate, NO3 1-, ammonium, NH4 1+, phosphate, PO4 3-, and hydroxide, OH 1-. Hopefully we've got these memorized. They are the key to unlocking our ionic nomenclature and writing our formulas. Speaking of writing some formulas, go ahead, pause it, write these 5 formulas for me. When you're ready, come on back and check them. Calcium phosphate, I'm getting in myself. Calcium bromide would be CaBr2, potassium hydroxide, KOH. Copper 2 acetate. Remember, the 2 is the charge on the copper. The copper is a 2+ charge. So to balance out, you're going to need 2 of the acetates. Got to have parentheses to get that 2 to apply to the whole polyatomic. Calcium phosphate, got to get them to be 6+, 6-. And ammonium sulfate would be NH4 parentheses 2, SO4. Should be able to go the other direction then. Go ahead, pause it. Name these for me. Watch out for your transition elements with the Roman numerals, except for aluminum, zinc, and silver. Iron transition. Looks like we got iron 3 sulfide for the first one, barium nitrate for the second, calcium acetate for the third, silver fluoride for the fourth, and copper 1 sulfate for the last one. That last one is kind of tricky to think about. You need 2 of them to cancel out the SO4 2-. So each one individually must be a 1+. Remember that Roman numeral is the charge on the copper, not how many of them there are. Watch out for that on that piece. Cool. Hopefully this helps in preparation for your test. You've got lots of practice items to be getting ready for your exam. Should you have any questions, feel free to email. I'll be available via our online resources all weekend.